two are two formats for our definition of a derivative. I'm going to get you started on the first one and see if anyone can finish it. And I'll show you how these show up on the AP exam. So it starts limit as h goes to 0. And we're going to go ahead and close the computer. We're getting out our bubble sheet. This is what's on the back of it. Limit is h goes to 0 of what? What have you got? It's f of something.
X plus h.
Perfect. X plus h minus f of x. You have to remember, in essence, it's a slope. It's y2 minus y1 over x2 minus x1, just with a limit in front of it. That's what makes it calculus. All right, over 8. Perfect. It is x plus h minus x. It's just the x's cancel out. Now that will give you the derivative in general, like f prime of x. If you want the derivative at a specific number, like you want f prime of 3 or something like that, its limit is x goes to c, and c would be the number. So it would be limit as x goes to 5 or whatever it is. You know, that would be a number. And it's the same thing. It's like a y2 minus y1 over x2 minus x1. You have to remember, in essence, derivatives are slope. It is regular old algebra 1 slope with a limit sprinkled on top. That's really all that it is. So those are our two formats of our derivative. And the way it shows up on the AP exam is in these limits. So if you take a look at a limit and you're like, yeah, that's going to be a nope from me, don't do it as a limit, do it as a derivative. And don't try to think too hard about it. You're just trying to pull out what the pattern is. Okay, so it's just pattern finding. So if you see something like this, do not do this as a limit. Not even L'Hopital's rule. This is, if you look at it and you're like, wow, that is a gigantic mess, do it as a derivative. You want to be like, hey, this is my derivative definition. We're going to find the function. We're going to take the derivative, and then we're going to plug in whatever number it is that they want us to plug in. So set it up blank like that. You want to find what's the function. That's just the pattern that you're going to pull out of it. We're going to take the derivative, and then we're going to plug in whatever number it is that they want us to plug in. So if you look at your pattern like this, it starts out f of x plus h and then minus f of x. So you kind of only want to look at this first part. Do you see this first part that I'm looking here? So our function is 2x cubed. Do you see how I got that? Because it's one of those things where I can't like force you to see it, but do you see it? It's 2 times something. Okay, good. Now we're not looking at this anymore. Well, until we have to figure out what number to plug in. Now we're going to do the derivative. So what's your derivative for 2x cubed? See how easy it is? It's a much easier problem. Now what are we going to plug in and hint it's not 0? That's the common mistake. 5. Perfect. We're going to plug in 5. Beautiful. 5 squared is 25 times 6 is 150. Again, like usual, I have a whole worksheet of this. I don't think we need to do every single one on here to feel like you've got it. Maybe let's do the odds, okay? Look at the next one down. Do you see how it's f of x plus h and then minus f of x? You want all of this part up until the subtraction. This 56 would be minus whatever you get once you plug the number in. Don't think about it too hard. Just pull out the pattern. What is the function that's going on here? Oh, you already get the answer? Hold on a second. Wait for me. What's our function? Yeah, f of x equals, I got that. 5x cubed. Yep, good. Plus 8x. Perfect. Okay, just don't think about it too hard. All right, there's a lot going on there. And then you're going to take the derivative of that. It's much easier to do it as a derivative than as a limit. So your derivative is perfect. And then it's not 0 that you want to plug in. It's 2. Good. This is the 2 that we're plugging in here. Oh, I'm waiting.
I missed that part. How come? Oh, wait, I think I got it. Yeah.
Now, if you were to plug 2 into this original function, you would get 56. Do you see what I'm saying? You can if you want, but if you plug 2 into this original function, you're going to get 56. All right, but we're going to plug 2 into the derivative. 2 squared is 4. Times 15 is 60, plus 8 is 68. I'm sorry it didn't come out to 67. Aww. Now this one has a delta x. Can you guys handle that?
Yeah.
It's just a different variable. Are a lot of you taking physics? Or currently in physics? If you're going from here to physics? No, okay. I've had people have to do that before, take calculus and physics back to back. It's a lot. All right, so we're gonna figure out what's the function. We're gonna take the derivative and then we're gonna plug in whatever number it is that they're telling us to plug in.
How do we know where to stop?
It's where to subtract. I'm glad you asked that. Did you guys hear that question? Do you see how the format is f of x plus h and then it's minus f of x? You want everything up until that subtraction. And again, the way that you can check it is once we decide this original function, here I'll show you. What was this? What this would be 2x cubed plus what? Plus 4x. And just skip a step, because let me show you how you can check it. What's the number we should be plugging in? It's not 0. 1. If you plug 1 into that original function, you should get 6. The 6 that's getting subtracted. So if you plug 1 in for x, you get 2 plus 4. 6. You see that there? That's how you can check it. Okay. Our derivative is 6x squared plus 4. We're going to plug 1 into that. We would get 10. Now, number 7, I would not do like this. You can if you want. It's following this pattern instead. But I'll be really honest, I would do L'Hopital's rule for that one. I think that that would be easier. If you plug in 3, you're going to get 0 over 0. So here, let's just do L'Hopital's rule. It would be limit as x goes to 3 of what? But I'm going to do this one as L'Hopital's rule. I wouldn't try to do it this way because I think it's just going to be easier. What would be our numerator if we do the derivative? 3x. Yeah, 3x squared. Good. Plus 1. That's a little tricky, right? Over, and then the denominator is just 1. That's why that rule works, is it simplifies it. And then you can just plug in 3. So it's going to be 3 squared is 9, times 3 is 27, plus 1 is 28. Cool. I don't particularly like this one. I'm not going to do that. Is there any other one that looks scary? Maybe we'll just do one more. 10? Okay. We're going to figure out what's the function. We're going to take the derivative. And then we're going to plug in whatever number it is that they want us to plug in. So again, if you see this on the AP exam, which it's likely you will as a multiple choice question, don't do it as a limit. If you read it and you're just like, that is horrible, don't do it that way then. You have options. Well, but it looks scary. Do you know what I'm saying? It's one of those things that looks really scary, but then when you work it out, it actually... Didn't we do a lesson one time? I was like, the worst math we did was like 2 times 3, but it looks super complicated. I actually really like that. That's one of those things, if your parents ask you what you did at school, you can just like whip one of those out. They will not ask you any more questions, I bet, if you just show them your calculus work, all right? So the function we're talking about is sine x. Good, so your derivative is cosine. And then I was meant to ask you that, but my brain just did it. What's the number we're plugging in? Number 2. I meant to ask you that, but I just went and wrote it because my brain got ahead of me. So we're going to walk, if you know the answer, that's fine. We're going to walk it through step by step. Where on your unit circle, and I'm looking for up, down, left, right, is pi over 2? It's up. That is the coordinate point, what, comma, what?
0,
0, comma, what? Here, you know what? I'll write that down. I love a good margin problem. That's literally your thoughts. That's your brain working, okay? Now, cosine is which part of that? X. So 0 is your answer. But if it was multiple choice, I guarantee you 1 would be one of the wrong choices. Okay?
Number 8.
Yeah, we can do number 8. Oh, so I don't think you're likely to see something like that on the AP exam, like 9 or 8. Do you see how it's not approaching a number? Like this is x approaches p and this is x approaches t. They're not going to do that to you. Can I show you that one later if you really want to see it?
I don't really want to see it.
Okay, I don't think they would do that to you. They would use an actual number, so it wouldn't be like that. Yeah, just go ahead and cross it out. I don't think you're going to. Here, I'll do it for you if you want, but can we make up a number? I just don't like when it's just t. Do you know what I'm saying?
4. 6, 7.
Let's say it's here. You know what? Actually, let me do the problem and then we'll figure out a number to plug in. So the function is 2 over x. How could you rewrite that? It would be 2x to the what? -1. Good. Okay, cool. So when you take your derivative, you're going to have to watch your negatives. You would bring the -1 down, so it's going to be -2x to the power Good. It becomes more negative. And so you can rewrite that as -2 over x squared. And then pretend it was a number, like just make up a number. I don't want to plug in t, that's stupid. It would just be 2. But like there's not enough 2's in this problem. All right. 2 squared, 4, so -2/4 would be -1/2. So pretend this was a 2 there instead.
Well, how would we do it without a number?
So the answer would just be -2 over t squared. Like you just replace the x with it. See, it's stupid. That's why I didn't want to do that problem. But I did it for you. It's fine. Like you would just take the x out and replace it with a t. And you wouldn't do any math. Like it just.
That wouldn't be, well, it shouldn't be on our even test.
No, they're not going to do that. I've never seen one like that. I've been doing this over a decade. I've never seen one like that.
So the